Good day, everybody. As you heard, my name is Matt Carman. I'm here to present to you Sandboxing with ESF Playground on macOS. A little bit about me. I'm a macOS security researcher at Conji. I have a background in, hopper crashing, malware analysis and detection, QA, and support. I'm a self-taught programmer, a father, and as you may be able to tell from my Twitter, I'm pretty quiet. These are some of the things that occupy my time outside of work. And just a little flex slide. My agenda today, I just wanted to go over my influences, some of the driving factors and goals for this. A little bit of the implementation. I did have a demonstration lined up, but it's struggling right now, so I'm just going over some of the details through that, and then some of the planned enhancements that I have. So first off, what is a sandbox? In relation to malware analysis and computer security, a sandbox is just an environment that you can run malware in safely and not have to worry about doing damage to the system and reset it to a clean state afterwards. Also, ideally, you're going to be recording any actions that are happening on the system, any network activity, so execution and file writing. What I'm not talking about is the built-in Apple Sandbox feature. So credit where credit is due. This program uses ESF Playground mainly, and Jaron Bradley over there created it, so it would not be possible without that utility. Also, some of my inspiration came from a product called Mac-a-mal Cuckoo. It was a customized Cuckoo sandbox for macOS that had a kernel extension with some pretty neat features. One of them being that you could disable SIP entirely and it would still report that it was on. Disabled all code signing with that, so you could run malware without checking code signatures, monitored everything on the system, and also had some really great detection features that brought up events that were actually malicious. The unfortunate thing is right before this thing was released, Meltdown and Spectre came out, and Intel systems had to change how they worked on the operating system level. Some instructions were disabled. So right before they released this, it broke, and they weren't able to get it running on the newest operating systems. If you were able to get it running, though, after some work, it was a really good system, recorded everything, and it was great to work with up until macOS 10.14. If you are interested in that, I can still get it to work on that, but it's Intel, so it will be going away. So it bears repeating that Apple devices are gaining more popularity, and so the desire to attack them. More companies are dedicating resources, like entire teams, to actually securing their Mac use case. And there's a huge gap in security knowledge between Windows, Linux, and Mac. Additionally, right now there's no sandboxing solution for Apple Silicon. x86 is on the way out, like I said. Cuckoo's gone. Any sandboxing solutions that do exist are really expensive, and you don't really get a lot of insight into what they're doing on the back end, so they're limited in that sense. So if you want to collect everything from a system, you can't do that. ESFriend is free, the application that I created, but it uses at least one physical Mac and paid third-party software to run. So the goals were to gain an understanding of how ESF Playground can be leveraged in our environment with changes made to our product here soon. I wanted to make something that was easy to set up, useful with minimal expense, again with the one physical machine that you need. The server can be configured to run on macOS, Windows, or Linux, so you only need that one macOS machine. So that could be considered a waste of a system, but I think it's worthwhile for this case. And also, this is my first time trying to collaborate with the Apple community, or Apple security community. I'm really happy to be here and share what I've found so far. So why physical machines? As we've all noticed, there's a lot of trouble with virtualization right now with M1 processors or Apple Silicon. A lot of anti-VM and anti-debug logic can be avoided just by using a physical machine, so we're hoping that that becomes less of a problem with this. And additionally, Phoronix Deep Freeze is the paid program that we just use to reset the system to a clean state after each run. I've looked into how this works a little bit, and it is using APFS snapshotting, I think, but in a way that doesn't make them reset it every time. So it creates a volume outside of the normal system drive that they write all the changes to, and then they just dump that afterwards. So moving on to my implementation details, ESFriend basically just started as a wrapper for ESF Playground. And we quickly found out dumping all these events into a database that we needed more context with all these events. There was a lot of information missing that we'd need to take action on things. So first would be by collecting a little more data from each event to try to fill out the gaps on that. And as we've seen, ESF is like a box of chocolates. They're changing it all the time, and each event is different. They all have their same special format. And until we see those events, we actually don't know how to process them correctly. So I'm working on trying to trigger every event, but I still haven't gotten there yet. And as you can see, there's a lot of events coming through. It's not very organized here, but the counts of events made me also realize that we needed to filter down these events quite a bit more. So the software is written in Python, and I wanted to use as few third-party libraries as possible, just because, as we've seen, they are being infected and becoming a security risk to install more and more. The configuration is done all through Brew, Python, ESF Playground, proxy. Submitting a file communicates only with the database, so it pushes this file to the database, and then the agent is running on a system that pulls the file from the database and tries to attempt to run it. Tries to attempt to run it is a key point, because right now it's really hard to automate execution of malware. So as I said before, all the communication is done through MongoDB. I don't have to open any ports on the analysis machine. All I have to do is just ask the server what's available and what instructions it wants me to do, and it will do that on the agent. A benefit of this, this essentially is just done by passing a football back and forth with job progress integer, and that increments whenever a new step is available. So the benefit of that using MongoDB is that we push those files to the server. Any additional files that are collected from analysis on the system are also put into MongoDB, so we're not cluttering the system with malicious files or PCAPs or anything like that. As I said, we're using man-in-the-middle proxy to capture all packets from the system. We are using a certificate, so that can be defeated a little bit easily depending on how they write it. But for the moment, it seems that nobody's really looking for that on macOS. So. When I display the results of what network activity is going on, I basically just printed the headers at first, and we have the PCAP available later if you want to look through all the traffic and even try to extract any data from it. So, as we know, the fire hose of ESF provides way too much information, so we need a way to filter out some of these events that are bad. What I've done is sort of created an event string that allows us to hash it and compare it quickly so that we can ignore certain events that we know are good. And I just do this by running the system for, 3 minutes, 5 minutes, 10 minutes, however long you want. Just collect all the information and then run a good list script to collect those events and create this list. This is imperfect right now. It might be filtering too well, so I'm working to tone it down so that I can collect more potential malicious events. And like I said, I was going to go through a demo, but unfortunately, the network here isn't allowing me to communicate between the systems. But And I was also trying to use my cell phone as the Wi-Fi network, and that wasn't working out very well either. Let me just go ahead and go over some of the results, though, just so I can kind of show what I'm collecting. And just so this is a good list run, you can see the amount of events that we're collecting just from, what was it, 1,800 seconds. So yeah, however long that is, I'm not going to try to do math on my head right now. Quite a lot of events. When we click into them, we can actually view the raw data and just try to scroll through that or search through that, but it's not very helpful. So filtering them down, actually, we'll do WinTape. You can see we lower the amount of events quite a bit when we filter them down, but as I said, I'm doing it too well, so a lot of the execution output is being missing right now. Also wanted to show the request headers at the bottom so we can try to find out what traffic is happening on the system just at a glance. That's the results screen. It is very basic, and somebody with a little more CSS knowledge would probably be able to make it look a lot prettier than this. But I'm a pretty simple person. So some of the planned enhancements I have for ESFriend is allow it to run as root so we can gather more files from the system that are dropped, because right now I can really only pull user files off the system because I'm not running as root. And this shouldn't be too hard to adjust everything. I also want to maybe implement some YAR rules for network traffic to catch some things that are pretty simple, such as shellcode. Wanted to also implement virtualization when it's ready, because right now none of the virtualization software is allowed you to control it through command line. Do more similarity matching of the condensed events or the event string with SSDeep. It might be possible that there's a way that we can do partial matching on that to find good events or bad events. I'd like to transform the output into something a lot better than it looks right now, but at the moment it's a good system that allows you to send the file to the system, run the malware, collect the events, and then reboot automatically so that you can start right over on the same file or the next file. Automated detonation is another problem, like I said. There's a lot of new features in macOS that make you right-click on files and select checkboxes to actually possibly remove the quarantine flag, but I haven't looked into that all the way. Custom ESF agent would be good as well. Disabling SIP may be possible, but I don't know if it affects the way that our recovery software works. So that's something I still have to test. Professional development polish would help, and I'm very open to suggestions. So I look forward to hearing any. Real quick, I just wanted to thank the creators of Mac-a-mal Cuckoo for their inspiration, Jaron Bradley, Cedric Owens, and Tony Piazza for helping me figure out which events are more related to malicious behavior, and of course, Kanji and Objective-C for the opportunity to be here. If you wanted to check out the project, it's available. It's published under GPL, so everybody can check it out and run it. I'm sorry I wasn't able to do a demo to show you that it reboots automatically and cleans the system automatically and restores pretty quickly, actually, to a clean state so that you can start over again and not have to wait for recovery. I also wanted to open the floor to questions and discussion if anybody had any.
Are you going to plan to add or look into some of the new ESF events from Ventura? Like some of the Xprotect stuff? Seems that would be particularly relevant to malware activity. Absolutely. Any new events that are added, as Jaron, if he adds them through the beta, then they would be helpful, of course. And I would definitely want to add every event. At the moment, I'm collecting everything from ESF Playground. I have every switch enabled. And it dumps a lot of information. One other thing that I'm also doing is collecting all the syslog events. So I'm able to, we have the, as I said yesterday, I'm dumping it all in JSON and just
pumping it into the MongoDB server as well. So we're collecting all the event streams, or the log stream, and I'm hopeful that that can reveal some more information, but it's a big fire hose as well that I want to try to filter down better.
Can I ask another question?
Yeah.
Have you played around with the new ESF utility that ships with Ventura?
Is it ESF Logger?
Yeah.
I have not, but I've heard of it.
Okay.
And I'm looking forward to trying it out.
Awesome. It is nice to see Apple kind of embracing and adding more utilities and capabilities. And
yeah, it'd be great to have all the features available from that as well. So.
Do you know or have you seen any other sandboxes related to the ESF or this thing important?
I don't know of any. I don't know about like Joe Sandbox or anything like that, but as far as I know, their output doesn't give us any ESF events. So.
Thank you.
You're welcome. Yes.
full of questions. This is a topic near and dear to my heart.
Yeah.
If you could ask Apple for one improvement, what would that be?
Ooh.
To make this easier, the development, or anything. One wish.
I'll be honest, this is a very simple program and it's very extensible as far as how you can modify it. So I didn't run into many problems with Apple technology in this. Yeah, it's basically just a simple data collector, and thankfully I didn't run into any snags with them.
That's great. Any other questions for Matt? Awesome. Let's give a round of applause again for Matt.
Thank you.